Hello, good morning to everybody. In today's video, we are going to discuss series part of the sequence and series. That is series, the summation we can say. So different types here. So this is a series. क्या होता है? Suppose you have to add 1, 1, 1, 1 n times. So obviously when you add 1, 1, 1 n times, it is simply it is equal to n. But what happens when it is added? We have to add 1 plus 2 plus 3 plus 4 like this n terms. So it is the arithmetic progression we have to add in this n times. So you have to use AP formula for n terms. So what is that? Similarly, if you have to add 1 plus 3 plus 5 plus 7 plus like this up to n terms. Suppose you have to add the squares of this like this up to n terms. If you have to add 1 cube plus 2 cube plus 3 cube plus n terms, this summation, this all summation we can write in one specific form that is called as summation. So we use the notation summation. Summation is given by this sign that is called as sigma. We use sigma sign, and for this, suppose you look at this one, 1 plus 1, 1, 1, 1 there. So we write this sigma 1, r is from 1 to n. Means you are using this 1, 1, 1 n times you have to add. So this is equal, this is nothing but 1 plus 1 n times. And the answer for this is n. If we use AP formula in this, then this can be written as sigma r. R is from 1 to n. That is 1 plus 2 plus 3. And by applying the arithmetic progression formula, it is always given by n into n plus 1 upon 2. That's the formula for sigma r. This next is the sigma r square. R is 1 to n, which is nothing but 1 square plus 2 square plus 3 square up to n square. For this, the answer will be n plus 1, 2n plus 1 upon 6. So, we can say it is an n terms, like this. Next, sigma r is from 1 to n r cube. So it is 1 cube, 2 cube, 3 cube, like this. The last will be n cube. The cubic expression is there. So answer for this is n into n plus 1 upon 2 the whole square. So whenever you want to find the summation is nothing but we can say the sigma of the general term of that particular series. If you want to find the sum n terms of that, so it is always given by this. So in this case, suppose 1 plus 3 plus 5 plus 7 you have to find. So you have to find general term first, and then you have to use this formula. So these are the standard formulas we are going to use. This 1, 1, 1 is 1 plus 1 plus 1. We are added as n time. The same formula can be written as sigma k. R is from 1 to n. If you add k n times, that will give you k into n. So this is the standard formula to find the sigma notation. So based on these few questions, this is the formulas for sigma. Sigma summation. Summation means what? Just addition of the given particular sequence. But obviously the sequence follows some rules, some pattern there. Here it is simply added 1, 1, 1, so answer is n. Here we are adding 1 plus 2 plus 3 up to sum of n natural number. This can be given as sigma r. So that is n into n plus 1 upon 2. Here sum of squares of the n natural numbers is given by n into n plus 1 upon 2n plus 1 upon 6. That is sigma r square. It is cube of the sum of the cube of the n natural numbers, which is n into n plus 1 upon 2, the whole square. So these are the direct formula we can apply. And the proof of this it is given in the text. We can refer that. But based on this, we will solve few questions now. So few questions from the textbook. The textbook question. Yes. So based on the series summation questions. Exercise 2.6, first question here, sigma r is from 1 to n, r plus 1 into 2r minus 1. So the basic rule we are applying always, if you multiply this 2, what happens? R will multiply into 2r, so it becomes 2r square minus r plus 2r minus 1, which is sigma 2r square plus r minus 1. So this is nothing but 2 sigma r square plus sigma r minus sigma 1, where r is from 1 to n every time. So now we will use that formulation here. So sigma 1, there is n sigma r square n plus 1 2n plus 1 upon 6, sigma r n plus 1 upon 2, sigma 1 is n. So like this, you can simplify this. This is cancelled here. So 3, LCM is 6. So you have to multiply this with 2 again. Or 2n. This you have to multiply with 3. This you have to multiply with this, and that is 6. Finally, so it is 6, and then you have to simplify this by taking common. So what is the common there? And n upon 6 is common in all. So taking n upon 6 as common, this is equals to n by 6 is taken common. So 2 into n plus 1 to n plus 1. 3 into n plus 1 minus 6. That is n upon 6. 2 into 2n square plus 3n plus 1 plus 3n plus 3 minus 6. So that is n upon 6, 2 will multiply, so become 4n square plus 6n plus 2 plus 3n minus 3. So that is finally is n upon 6, 4n square plus 9n minus 1. So that is the answer. So answer is n upon 6 into the bracket 4n square plus 9n minus 1. So this is the answer for this question. Exercise 2.6, first question. Here the next question, question number 4. So in this we have to find the sigma r is from 1 to n in this bracket. So it is a sigma of whatever the answer of this, the sigma of that. So the sigma sign is for the whole bracket. That means you have to find first the sum of this. And that formula we already know. What is the sum of this? The cubic expression is n sigma r is from 1 to n is equals to, what is this? It is r into r plus 1. R into r plus 1 upon 2 the whole square. Upon r into r plus 1, like this. So r into r plus 1 will get cancelled. So that will cancel and one term will remain. So it is sigma r is from 1 to n, r plus 1 upon it will be 4. Because 2 ka r into r plus 1 cancel, but the square is there. So this 2 ka square 4 ho jayega. And therefore it is 1 upon 4. It is sigma r square plus sigma r. Now this 1 by 4 is for both. R is from 1 to n, like this. What is the sigma R square formula? So sigma R square formula here, it is n plus 1, 2n plus 1 upon 6. n plus 1, 2n plus 1 upon 6. What is sigma R formula? It is n plus 1 upon 2. So taking LCM here, 1 by 4, n plus 1, 2n plus 1 upon 6. So LCM, we multiply this by 3n, like this. And then n into n plus 1 is taken as common, so it is and 6 also. So it is 1 of n into n plus 1 upon 24. 6 into 4, 24. So बचेगा क्या अंदर? 2n plus 1 बचेगा. और इधर क्या बचेगा? सिर्फ बचेगा 3. So that is 2n plus 4. So n into n plus 1, 2n plus 4, 24. Again 2 common and cancel with this. So it is n into n plus 1, n plus 2 upon 12. So that is the answer for this. So this is a very simple. You have to find the summation of this, and then you have to use sigma notation. So sigma notation, sigma means the sum. Sum from R is from 1 to n. That many term, that summation is there. Yes, so next question number 7 in this. So in the 7th question, find the sum of 70 square minus 69 square plus 68 square minus 67 square plus 66 square minus 65 square, like this. To the last bracket is 2 square minus 1 square. If you observe this, the first digit here is the sum number square and the second one is odd. So we'll make it 2 separate brackets for this. It is better, that is 70 square, 68 square, 66 square, like this. The last one will be 2 square. And the next bracket, you can see the minus is taken common. So 69 square plus 67 square plus 65 square, like this. The last will be 1 square. Now there is 35 terms will be in one bracket and 35 terms is in the second bracket. Total terms are 70, out of which 35 here. Understood this one? So now this is the summation of 35. So what is the nth term? We can write this in the reverse way. That is 2 square plus 4 square plus 6 square up to 70 square minus 1 square plus 3 square plus 5 square up to 69 square, like this. So here we can write this as sigma R is from 1 to 35, because n is known to you, and this is an even number. So even number we can say, even number is always expressed as 2r, so it's 2r plus 1. Here 1, so it is sigma R is from 1 to n is 35 again here. 2r minus 1, 2r plus 1. That is the possibility of the even number. So it is 2r minus 1 substitute here. So when r is equal to 0, it is there is right. But when r is 2r plus 1, r is 1, it is 3 will come. 2r minus 1, when r is 1, it is 1. So 2r minus 1 is the correct one. So 2r minus 1 ka square, because when the first number is 2 minus 1, so 1 square. The last is 35, 70 minus 1, 69, so we call it as 1. Same means here, 2 square, and add 35, that is 70. So this is exactly, now the matching is there. Now since both r is from 1 to 35, we can take it common also. We can take it common and then subtract in one sigma, because sigma to value we have 1 to 35, 1 to 35 cell. So we can take this in 1 sigma under 1 sigma. R is from 1 to 35. So it is 2r square plus square, 4r square, is the square angle minus 4r square minus 4r plus 1. This 2r the whole square, so this 4r square minus 4r plus 1. And then you have to subtract. So 4r square get cancelled. So it is sigma r is from 1 to 35, 4r minus 1. It is 4r minus 1. So 4r minus 1 means it is a sigma 4 sigma r minus sigma of 1 to 35. It is 1 to 35. So for this 4, the formula is n plus 1 upon 2, but here it is 35. 35 plus 1 upon 2, and here it is 35 times. This is cancelled with this is 2. So it is 2 into 35 into 36 minus 35, like this. 35 is taken common out of this. 35 is taken common, so it is 2 into 36, it is 72 minus 1, so it is 71. So it is 35 into 71. And the answer for this is 71 into 35. 5, 3, 2485. So answer for this sum is 2485. So that is the way we have to solve it. Here, so next question, 1 into 3 into 5, 3 into 5 into 7, 5 into 7 into 9, up to n terms, we have to find the sum of this. So otherwise, in this type of, any type of the sequence or series, the pattern is there, then that is not difficult. There is a pattern. If you observe this, 1, 3, 5. So there is a pattern that 1, 3, 5 in AP number 1. The next sum, 3, 5, 7. This is in AP number 2. And the third term, 5, 7, 9. That is in AP number 3. And this all AP has a common difference as 2. So the first term in this is the 10th term. So the rth term will be PR is equal to what? A plus R minus 1B. So this is 2. So it's 1 plus 2R minus 2, which is 2R minus 1. In the next term, the next AP, so only the 2 is different, so you have to add 2 in this. TR for the second AP is 2R plus 1. And for the third AP, the TR will be 2R plus 3. Like this. So that means that this sequence, now this sequence 1 into 3 into 5 plus 3 into 5 into 7 plus 5 into 7 into 9 up to n term can be written as it is the sigma of TR. R is from 1 to n, and TR is nothing but TR. The TR Rx term for this is nothing but 2R minus 1, 2R plus 1, 2R plus 3. Because you put R equal to 1, you get 1, 3, 5. Put R equal to 2 in this, 3, 5, 7. Put R equal to 3 in this, 5, 7, 9. So like this, the sequence is matching. Therefore, it is sigma R is from 1 to n, 2R minus 1, 2R plus 1, 2R plus 3. Like this, and then we have to evaluate this. So that is very lengthy evaluation, but we can easily still evaluation is possible. This 2 multiplication pass. So that is sigma R is 1 to n. It is 4R square minus 1 into 2R plus 3. Then again this multiply here. So it is sigma 2R into this 8R cube minus 2R 12R square minus 3. So that is sigma AR cube plus 12R square minus 2R minus 3. Like this. At R cube, 2R. So that is nothing but 8 into sigma R cube, 12 into sigma R square, 2 into sigma R minus 3 sigma 1. So we can apply the formula for the sigma R cube, that is n plus 1 upon 2 the whole square plus 12. As per the formula, n plus 1, 2n plus 1 upon 6. Sigma at the formula, n plus 1 upon 2. The sigma 1 is this 2 cancel. 6 cancel 2. This is 4, so cancel is 2. So it is 2 into n square, n plus 1 the whole square. This is 2n square plus 3n plus 1. Here it is cancelled, so minus n square minus n, and this is minus 3n. Minus n square minus n minus 3n. So it is 2n square 2n 1 plus 4n cubed plus 6n square plus 2n minus n square minus 4n, which is finally 2n cubed, 2n raised to 4, it is not square, 2n raised to 4 plus 4n cubed plus 2n square plus 4n cubed plus 6n square plus 2n minus n square minus 4n. So this 2n raised to 4, n cube में 4n cube, this become 8n cube, square में this and this. So what is this? It is 7n square, because 2 plus 6 8 minus this becomes 7n square. And n में बचा अभी 2n minus this, so that is minus 2n like this. So 2 plus 10, 10 plus 7, that is right something. So this is the final answer for this expression here. Yes, so next question, question 9 here. So what is that? 1 into 2 plus 2 into 3 plus 3 into 4 up to n terms, and upon 1, 2, 3 like this up to n terms. The ratio is given as 100 upon 3. Then the question is what is n? So it is quite easy here. General term here will be r into r plus 1, because 1 into 2, the next is 2 into 3. So it's put when r equal to 1, so it's 1 into 2. When r equal to 2, it is 2 into 3. Similarly, it is सीधा है, so it is sigma r. It is sigma r from 1 to n. If you have to solve it separately, separate numerator, separate denominator. Don't do it common together. So that's very crucial in this. So we can solve separately. So what separation will we give you? Sigma r square plus r. Sigma r square plus sigma r upon sigma r, like this, is equal to 100 upon 3. Is from r is from 1 to n, r is from 1 to n, r is from 1 to n. Now sigma r square formula is n plus 1, 2n plus 1 upon 6. Sigma r formula is n plus 1 upon 2. नीचे वाला n plus 1 upon 2, and that is equal to 100 upon 3. So n plus 1 upon 2 is common and cancelled from the numerator from both the sides. So n plus 1 upon 2 cancel out. from numerator as well as denominator. This term is cancelled. Here, so n plus 1 upon 2. So what is remain there? 2n plus 1 upon 3. इधर बचेगा a, इधर बचेगा a, and that is equal to 100 upon 3. That gives you 2n plus 1 plus 3 is equal to 100 upon 3. So that is 2n plus multiply होगा 6n. This is 4 into 3, so it's 12. So 6n is equal to 88. It will be 2n plus 1 plus 3 upon 3. Sorry, it is upon 3 बच रहा है. So this 3 cancel होगा. So it is 2n plus, it should be 2n plus 4 is 100. Yes, so this 2n is equal to 96. So n is equal to 48. So answer is n should be equal to 48 here. So it is n is equal to 48. That's the correct answer for this. Yes, so one more question. So this is prove that sum. S1 is the sum of first n natural number, S2 is sum of the squares, and S3 is the sum of the cube. So we know solution as per given condition. S1 is sigma r from r is 1 to n, which is n plus 1 upon 2. S2 is sigma r square from r is 1 to n, which is n plus 1 to n plus 1 upon 6. And S3 is sigma r cube, r is 1 to n, which is n plus 1 upon 2 the whole square. Now, if we take LHS here, so LHS is 9s2 square. So 9 into s2 square, so 9 n plus 1, 2n plus 1 upon 6 the square. That becomes 9 upon 36, so it is, so 9 upon 36, which is 4. We can say n plus 1, 2n plus 1 into 9 upon 36. This is square and this is Alex. This cancel out here, so it's become 4. And therefore we can write this as n plus 1, 2n plus 1 upon 2 the whole square. That is your LHS. Now we will move to the right hand side. So right hand side is S3. 1 plus 8 into S1. So S3 here is n plus 1 upon 2 the whole square, and S1 is n plus 1 upon 2, like this. So it is n plus 1 upon 2 the whole square. It is as it is. Now we have to simplify this. So what is this? It is 2. This is cancelled here. So it is 4. So 1 plus 4n square plus 4n, which is nothing but it is 2n plus 1 the whole square. So it is 2n plus 1 the and that can be a club with this, so therefore it is n plus 1, 2n plus 1 upon 2 the whole square, and that is equal to LHS. Hence proof, because that is there. So after simplifying, we get 2n plus 1 the whole square, and this club with this in this one square, so that is the left hand side. So it is very easy proof, yeah. So that's it. That is all about the series part of this. So again, the sequence and series we complete here. So I'm sure you may have enjoyed this. So just go through all the videos properly. and make your notes. Try to solve the sums, numericals which are not done from the textbook, and then also solve few MCQs for the practice as well. So, and in MCQs I will discuss now one more lecture, the shortcut tricks, the next lecture. Thank you. Hello, now we will discuss MCQs of JEE level based on the concept whatever we discussed till now. So now here the next question number 37. 1 plus 3 plus 7 plus 15, 30 plus 31 is up to n term. Now in this case, always this type of summation first we should know TR. If you can find TR, then it is sigma TR. But the series question is there, is always sigma TR, so we can easily solve it. So what is summation of this? That is very important. If you observe this particular term, it is 2 minus 1. What is this? It is 4 minus 1. What is this? It is 8 minus 1. But it is very difficult to click. If you click, then it's very easy. So we can say that the general term TR is 2 raised to R minus 1. Because if we put T1, it will be 2 1 minus 1, that is 1. T2, it is 2 square minus 1, which is 3. T cube, that is 2 cube. T3 is 2 cube minus 1, which is 7. So it is 1 plus 3 plus 7 and 15 in all. So this is the summation. So now here, so this is the required summation. This summation of 2 raised to r minus 1. R is from 1 to n. This you have to do. So in this case, what is the summation? So now r equal to 1 in this is 2 raised to 1, 2 raised to 2, 2 raised to 3 up to 2 raised to n. And here it is 1, 1, 1 n times, so it is n. Now this is a geometric progression. This is a geometric progression with the common ratio is 2. And the common ratio and first term also 2, so it is 2 into 2 raised to n minus 1 upon 2 minus 1. And this is n. So 2 minus 1 is this. So 2 multiplied here is 2 raised to n plus 1 minus 2 minus n. So this is our answer. The answer is 2 raised to n plus 1 minus 2 minus n. So this is the method is applicable if you can easily identify what is the rth term of this. Otherwise we can solve the same question by the shortcut method also. So that method which we have discussed already. So see that method also. Yes, so next question number 37 here. So 37 is 1 plus 3 plus 7 plus 15 plus 31 up to n terms, and the options are given to you. So now in this, why I have written the options here? Because we are not going to solve it by conventional method, because it is not easily observed that is ABCD. It's not ABCD form. It's a random sequence. And when the random sequence and the options are also given, it is better to go in the option method. So what is option method? We consider n as 3. We say n is equal to 3. If n is equal to 3, you add first 3 terms. Add first 3 terms. So what is that? 1 plus 3 plus 7, that is equal to 11. 1 plus 3 plus 7 is equal to 11. Now we put in option number 1, in option 1, put n is equal to 3. Put n equal to 3 in the first option, that gives you 2, 3 plus 1 minus 3. So that is 2 raised to 4, which is 16 minus 3. So it is 13, which is not matching, so this is the wrong option. Next, option number 2. Option number 2. It is this, that is 2 raised to n plus 1 minus n minus 2. So here, if you put n is equal to 3 in this, it becomes 2, 3 plus 1 minus 3 minus 2. So that is 2 raised to 4, which is 16 minus 3 minus 2. That becomes 16 minus 5, which is 11. So it's matched with this. So option 2 is the correct answer. So the correct answer is option 2. For our set, we can put the n equal to 3 in this. What will happen? 2 cube, which is 8. 8 minus 3. And this becomes 3. So it's not. So option 2 is the correct. You can check it by taking first 4 term also. If you have doubt because of none of this, take n equal to 4. N equal to 4 means you have to add 4 term and then you have to check. So it is like this. It's very simple one. So you can proceed with this type. Whenever there is a random, we cannot say it is an ABJP. It is a random sequence is given. The sum is given and options are also available. We can go by this method. That is very easy method. Here, if you have there is 2 matching options, we can take n equal to 4, n equal to 5, like that. The first you can add first 4 term, you can add first 5 term and put n equal to 4 or 5 in the given option and check what is matching here. So that's, I think it's very easy method, right? Yes, so here the next question of series is given that 2 plus 4 plus 7 plus 11 plus 16, what is the sum of n terms of this series? Now, this is not ABGP or nothing, and thus very difficult to identify directly the TR. So what to do in this type of question? So remember that here, if you observe this, the difference is 2, this difference is 3, this difference is 4, this difference is 5. Means the difference counts in 8, so that difference will be 6. So when this type of difference we observe, we can easily do this. We can easily find its TR. How to find TR for this? Write down as it is. 2 plus 4 plus 7 plus 11 plus 16 to the nth term, nth term, r terms. Okay, now what is the next s here? So I am writing the same again, the same sequence again, but starting from here 2. The next is 4, is 7, 11, like this. So there is one extra term to come here, so that extra term is nothing but TR. TR. One TR will remain here in this. And in the previous case, that is a TR here. So TR in the previous, this value, the subtraction of this here, if you do the subtraction, S minus S is 0. This 2 remains as it is. This 4 minus 2 is 2. This is 3. This is 4, 5, like this. The last one will be R is 5. So first term is 2, so the last will be R. And the next is TR here. TR. So, sorry, it will be negative. So minus TR because it's subtracting. So what is the value of TR in this case? Therefore, TR is 2 plus 2 plus 3 plus 4 plus up to R. Now 2 we can split as 1 plus 1 plus 2 plus 3 plus up to R. Now we know what is this value here. This 2 is split as 1 and 1. And what is the summation of 1 plus 2 plus 3 plus R? Then we know it is R plus 1. So TR will be 1 plus R plus 1 upon 2. So this is the general term. This is the general term for this expression. You can cross check this one. When R equal to 1, it is 1 into 2, that 2 will get cancelled. So this term is 1, 1 plus 1 is 2, so that is there. When R equal to 2, it is 2 into 3, which is 6. 6 upon 2 is 3. 3 plus 1 is 4. So that is there. That means the general term is right. Now we want to find the sum of this. So therefore the required sum, the sum is summation of TR. R is from 1 to n. Like this. And then that is nothing but 1 plus R into R plus 1 upon 2 the summation. You have to do the summation of this. The summation of R is from 1 to n. The summation of this. That we have to do. So let's summation of 1 is nothing but n, so that is we already know. The summation of this is there, and then 1 by 2 is taken common, the summation of sigma r square plus summation of sigma r. This is 1 by 2 for both. So we have to simplify this. So what is this? N plus 1 upon 2, the value of this is n plus 1, 2n plus 1 upon 6, that's the formula for this. Here, n plus 1 upon 2, that's the formula. So clearly from both, what is the common here? Yes, so here after this, n, this is sigma r square formula, n plus 1, 2n plus 1 upon 6, sigma r, n plus 1 upon 2. So now, take LCM, दोनों बाजू का denominator same करते हैं. So n as it is 1 upon 2. 6 is there, so you have to multiply this with 3. n plus 1 to n plus 1 upon 6. Here you have to multiply with 3. So it is 3n, because to make the denominator same. Now denominator same हो गए. Now common n plus 1 upon 6 is common. So क्या बचेगा इधर? n plus 1 upon 2. n plus 1 upon 6 बाहर, अंदर बचेगा 2n plus 1 plus 3. 2n plus 1 plus 3, that is 2n plus 4. n plus 1 upon 2, n plus 1 upon 6, 2n plus 4. Again 2 also common and cancel. So it is n plus 1 upon 2, n plus 1, 2 common, n plus 2 upon 6. So this 2 and this 2 also cancel out. So here again we take 6 as an LCM. So this becomes 6n plus n plus 1, n plus 2 upon 6. Like this. So now n is common. 6 plus n plus 1, n plus 2, because n by 6 is common, so n by 6 baहर करो. So now it is n by 6, 6 plus n square plus 3n plus 2, which is nothing but n by 6, n square plus 3n plus 8. So this is the final answer. N by 6, n by 6, n square plus 3n plus 8. Because substitute the value, so n equal to 2, the sum should be 6. So when you put n equal to 2 in this, 4 plus 6, 10, 10 plus 8, 10 plus 18, so that is 3. And into this 2, so that is 6, so that is 9. So put n equal to 2, this gives you 6. So 2 plus 4 is 6, this also 6. That means the verification is done. The same question which can be solved by easy way, that is the shortcut method, which is also we have already discussed. So see that. Yes, the next quite similar question, question number 38, same as that of 37. That is 2 plus 4 plus 7 plus 11 plus 16, and terms and options are available. We cannot say it is ABGB, so again we go with our method, that is put n is equal to 3. So put n equal to 3. So addition of first 3 term, 2 plus 4 plus 7, that is equal to 13. 13. And now options. So option 1. So option 1, 1 upon 6. 3 square plus 3 into 3 plus 8. So what is this? It is a 9 plus 9. 9 plus 9, 18. 18 plus 8, 26. So it is 26 upon 3, which is 26 upon 6, which is not correct because we give you 13 upon 3. Option 2. So option number 2 here, n by 6. So n by 6, n is 3. So it's 3 by 6. The middle value is the same, so it is 3 square plus 3 into 3 plus 8, so that is again 26. So 1 upon 2, 9 plus 9, 18 plus 8, 26, so 26 upon 2, 26 upon 2, which is 13, so it is correct. If you have doubts in the option 3, we can check for option 3 as well. Option 3, 1 upon 6, 3 square minus 3 into 3 plus 8. So 9 minus 9 is out, so it is 8 upon 6. And option 4, again this middle value will be 8, and that is, so option 4 is no wrong. Option 4 is also wrong, because this would be 3 by 6, and the middle value will be 8. So it is 8 by 2, which is 4, which is again wrong. So correct answer is only this. So that is the option 2. So here the option 2 is the correct answer. Option 2 satisfies this. That is, the sum of first 3 terms is 30. We put n equal to 3 in this, and that become 26 upon 1 upon 2, and that gives you 13 as well. This is a very easy method, isn't it? Yes, so here the additional few questions we will solve based on series. The special type of series is there, 1 upon 2 plus 3 by 4 plus 7 upon 8 plus 15 by 16. So always when the series type of question is there, you have to find the general term and the summation of that. That up to n is the answer. So what is the, by observing this, the TR for this is, what is the TR here? It is 1 is nothing but 2 minus 1. We can just observe this is 2 minus 1 upon 2. This is 4 minus 1 upon 4. This is 8 minus 1 upon 8, and so on. Which is nothing but 2 raised to 1 minus 1. This is 2 square. This is 2 cube. So what is the general term? Therefore, TR, which is equal to collected from this. So this is the general term for this particular series. So summation is S is equal to, it is a sigma R is from 1 to n 2r minus 1 upon 2r, 2 raised to r. By separating this, we can say that it is a sigma R is from 1 to n, separating this 1 minus 1 upon 2 raised to r, which is, when you put the values here, some sigma 1 is nothing but n. And minus sigma, putting the value here, it is 1 upon 2 plus 1 upon 2 square plus 1 upon q cube, like this, upon 1 upon 2 raised to n. So which is in GP, geometric progression of n term with the common difference, or your common ratio is 1 upon 2. So using that formula, 1 upon 2 as a common ratio, the first term is 1 by 2, 1 minus 1 upon 2 raised to n upon 1 minus 1 upon 2. That is a formula for Sn for geometric progression. So it is n minus 1 upon 2, 1 minus 1 upon 2 is nothing but 2 raised to minus n here, and this is 1 minus is again 1 by 2. So 1 by 2 get cancelled. So answer will be n minus 1 plus 2 raised to minus n. So which is there in the option. Look at the option there. It is option number 3. Yes, it is option number 3 is the correct answer for this. It's matching with this. So third is the correct answer. So in this type of question, important is to find general term TR, and the summation of that is the requirement of the series up to n term. That's it. Yes, so here one more question. That's the second question here, that is 12 plus 16 plus 24 plus 14 up to n terms, and this is, the options are there. So the question, before going to the question, if you observe this, the difference between these two terms, 12 and 16, is nothing but 4. 16 and 24 is 8. This is next is 16. So it is just going 4 and 16 in geometric progression. So when this type of the difference is there, which is in the form of AP or GP, we always subtract sum minus sum. We do the sum minus sum concept here. So AC is equal to 12 plus 16 plus 24 plus 40, and then the S But we write here 12 plus 16 plus 24 plus, so the last term will be TR. And then we subtract this, the S minus S will be 0, 12 will remain 12. This is 4, 8, 16. So this concept is always applicable for, but it is R minus 1 terms and then TR. So TR is equal to what? Therefore TR is equal to 12 plus 4 plus 8 plus 16, like this, R minus 1 terms geometric progression. So it is the geometric progression where the first term is 4 and the ratio, common ratio is 2. So it is 12 plus 4 into 2 raised to R minus 1 upon 2 minus 1. So that is there, that is the TR. We multiply 4 in, so it is 12 plus 4 into 2 raised to R minus 1 minus 4. So that is the TR for this. So TR will make about S is always the summation of TR. The summation of TR from R is 1 to N, and that is summation of 12 plus 4 into 2R minus 1 minus 4. So that is 12 minus 4. We can directly write this as 4 into 2 raised to R minus 1 plus 8. So it is 4 into 2R minus 1 plus 8. And now we will solve this. So here it is 4 as this. So we will solve this 4. The first value in R is equal to 1, which will be 0. So 2 raised to 0 will come. Means 1 plus 2 raised to 1, 2 raised to 2. Like this, 2 raised to N minus 1 will come. And this is again geometric progression with the first term is 1. First term is 1, so it is N number of terms will be there. So it is 2 raised to N, 2 raised to N minus 1 upon 2 minus 1 plus summation is there. So summation the logos will be there. The summation will be 8N area. So it is 8N. Summation will be 8N because sigma of 8 is 8N. So it is 8N. And now what is the C? So it is 2 minus 1 is 1. So 4 will multiply with this. So 4 into 2 raised to N minus 4 plus 8N. That should be the correct answer. Or we can say it is 4 common 2 raised to N minus 1 plus 8N. So which is there in the option. So that is 4th option here, which is the correct one. So remember that this is here. Just nothing but to solve the sum properly. You will find TR and then summation of that. That is the second example here. Now here, this is a special type of sums, but it's very easy. When shortcut method, shortcut tricks like in the next lecture, it is very easy to solve by shortcut way also. But by conventional way, how to solve? So you can observe this. This is 2 into 4, 4 into 6. The difference between this is 2, 2, 2. This difference is 3, 3, 3. So this standard difference, this type of series is there. So in this type of series, the first job is to find what is Tn. So what is Tn for this? That is very important. Clearly, this is 2. So it is 2r and this is 2r plus 2. Then r equal to 1. That is the even numbers. So 2r and then 2r plus 2. If you want, you can go with this also 2, 4, 6, 8. It is the first AP and 4, 6, 8, 4, 6, 8, 10 will be the second AP. The AP number 1, this is AP number 2. And by using the Tn formula, Tn is equal to A plus N minus 1B, N minus 1 into 2. That is 2n minus 2, so it is 2n only. If here we use the same formula, so Tn is 4 plus n minus 1 into 2, so it is 4 plus 2n minus 2, so it is 2n plus 2. That means the general term for this particular series is Tn is equal to 2n, 1 upon 2n into 2n plus 2. That is the general term for this particular series. So how to solve this? How to solve this series? See here. In this case, we write this series with the difference. Whatever the difference is there, multiply and divide by that difference. So your difference is 2. So divide by 2 and multiply by 2. So first of all, I am writing the same series. That is S is equal to 2 into 4 plus 1 upon 4 into 6 plus 1 upon 6 into 8. Last term will be 2n plus 2. Then multiply by 2 and divide by 2. So 1 upon 2, 2 into 2 into 4 plus 2 into 4 into 6 plus 2 into 6 into 8 plus 2 into 2n plus 2, like this. It is there. Then this 2, we write this 2 as 4 minus 2. If this write as 4 minus 2, 2 into 4. 6 minus 4, 4 into 6. 8 minus 6, 6 into 8. Like this. 2n plus 2 minus 2n upon 2n into 2n plus 2. So this is divided by 2, multiplied by 2, then this 2 will existing like this. The reason of existing is, now we split. So after splitting, 4 upon 2 into 4 minus 2 into 2 into 4. Similarly here, 6 into 4 into 6 minus 4 into 4 into 6 plus 8 upon 6 into 8 minus 6 into. So like this, the last one, 2n plus 2 upon 2n into 2n plus 2 minus 2n upon, like this. So after splitting, so now this 4 and this is cancelled. Here 2 will get cancelled. So it is 1 upon 2, 1 upon 2 minus 1 upon 4. This 6 is cancelled. So it is 1 upon 4 minus 1 upon 6 plus 1 upon 6 minus 1 upon 8. So automatically this middle terms, all middle terms are going to get cancelled out. The only remaining term is first and the last. So what is the last term here? The last term is 2n plus 2. So this is the first term and the last term will be the remaining. So rest term automatically cancel out. So it is a 1 upon 2 minus 2n in fact it is 1 upon 2n plus 2 because 2n also get cancelled. So that is the last term remaining. The last term remains 1 upon 2n plus 2. So now this 1 by 2 will take in, and then otherwise you can simplify here on this 1 upon 2 as it is. This is 2n plus 2 minus 2 upon 2 into 2n plus 2. 2 to cancel. 2 to cancel, so it is 2n. Is 2n upon 4 in fact it's 8 into n plus 1 because 2 is out, so 2 is common, 2, so 2 into 2 into 2 that become 8 and ऊपर से बचा है 2n. So this is 2 cancel with this, so that become 4. So answer is n upon 4n plus 1. So answer is the second option for this. So this type of question is very easy one, but there's a pattern here. The difference is constant throughout, and then you can use this pattern. This can solve easily by using shortcut trick also in the next lecture. Yes, so similar question as already discussed. So same type of question is that there is a factor of common difference. That common difference is T, 3 here. So first of all, we'll find TR, yeah, TN, general term. So here 2, 5, 8 is the first AB number 1. So for this TN is 2 plus n minus 1 B. So that is 3. 2 plus 3n minus 3. So it is nothing but 3n minus 1. The next term is just we have to add, that is 5, 8, 11, like this. We have to just add 3 in this. So that 3 and this automatically will be what? 3n plus 2. So when n is equal to 1, that is 2. And here it is when n is equal to 1, that becomes 5. So 2 into 5. n equal to 2, it is 6 minus 1, 5. And this is 8. So this is your Tn. So here the s will be x is equal to 1 upon 2 into 5, 5 into 8, 8 into 11, dot, 1 upon 3n minus 1, 3n plus 2. And you know here the difference is 2, so multiply divided by, difference is 3, so multiply divided by 3. And the purpose is also known to us as a previous sum, 2 into 5 plus 5 into 8, 3 upon 8 into 11, dot, 3 upon 3n minus 1, 3n plus 2. And then this subtraction, so 3 is nothing but 5 minus 2. 5 minus 2, 2 into 5. 8 minus 5, 5 into 8. 11 minus 8, 8 into 11. Like this. 3n plus 2 minus 3n minus 1 upon 3n minus 1, 3n plus 2. And then, if you split it, so it is 1 upon 3. Then this is cancelled 5, 5, so it's 1 upon this, minus 1 upon 5, 1 upon 5, minus 1 upon 8, like this, the middle term all will get cancelled. The last term is minus 1 upon 3n plus 2. So this is there, so answer will be 1 upon, the all middle term will cancel, only the first term and the last term will be there. So after simplifying this, 3n plus 2 minus 2 upon 2 into 3n plus 2, which is 2 to cancel. This finally this 3 also cancels, so it is n upon 6n plus 4. So that is a correct answer for this. So that is the first option in this. So it is similar to that of the previous question. So you can remember this one. This is an easy method which you have to apply. That is when there is a common difference in this type of series.